There is a galaxy sitting at the edge of the observable universe that should not exist. Not shouldn't exist in the way scientists say something is rare or unlikely or surprising. I mean it in the most literal sense possible. According to every model, every simulation, every equation, physicists have spent decades building and testing and refining this object cannot be there. And yet there it is. Its name is JWST. And before this video is over, I'm going to explain to you exactly why its existence is one of the most unsettling discoveries in the history of modern science, and why almost nobody outside of the astronomy community is talking about it the way they should be. Because here is the thing. We did not just find a galaxy in an unexpected place. We found evidence that something happened in the first chapter of the universe that our best physics cannot explain. We found oxygen where there should not have been time to make oxygen. We found stars that lived and died before there should have been enough time for them to be born. We found a fully assembled, blazing, mature galaxy in an era of the universe that was supposed to be dark, quiet, and nearly empty. The James Webb Space Telescope was built at a cost of $10 billion and 30 years of engineering to answer questions about the early universe. Nobody expected it to come back with questions of its own, but that is exactly what happened. To understand why this matters, you need to know what the universe was supposed to look like at the beginning. After the Big Bang, all you had was hydrogen, helium, and trace amounts of lithium. For the first 380,000 years, the universe was too hot for atoms to even hold themselves together. Just a glowing, opaque plasma. When it finally cooled, atoms formed, light escaped, and then the universe did something nobody talks about enough. It went completely dark. No stars, no galaxies, no light anywhere. Just warm hydrogen gas, slowly drifting and clumping under gravity for roughly 100 to 250 million years. Astronomers call this the cosmic dark ages, and the name earns itself, an entire universe of silent, expanding black fog. Eventually, the densest gas clouds collapsed under their own gravity, and the first stars ignited. These were not stars like our sun. They were monsters, possibly 200 to 300 times the mass of our sun. Burning so hot, they only lasted a few million years before exploding as supernovae. But in that short time, they did something crucial. They fused hydrogen and helium into heavier elements, carbon, oxygen, iron, and when they died, they scattered those elements into space. The next generation of stars formed from that enriched gas. Then galaxies slowly assembled piece by piece over hundreds of millions of years. That is the standard story, tested, verified, trusted. The Lambda CDM model, the cosmological framework that has guided astronomy for decades. And then, in a historic moment for modern astronomy, the James Webb Space Telescope launched. Before Webb's first images came back, the astronomy community had reasonable expectations. The telescope would see further than Hubble ever could, back to the first galaxies. But those galaxies would be small, faint, and primitive. Scattered proto-galactic clumps barely registering above background noise, campfires at the edge of time. The JADES program, the JWST Advanced Deep Extragalactic Survey, was designed specifically for this hunt. Hundreds of hours of telescope time, dozens of international researchers. One goal, find the first galaxies and map the moment the universe lit up. What they found instead nearly broke their data pipeline. JWST Z14 sits at a redshift of 14.32. Here's what that number means in plain English. The light from this galaxy has been traveling toward Earth for 13.5 billion years. We are seeing it as it existed when the universe was just 290 million years old. Barely 2% of its current age. The light that left this galaxy started its journey when the universe was practically a newborn. It has been crossing expanding space ever since, getting stretched from ultraviolet all the way to infrared. Its wavelength now 15 times longer than when it was emitted. Webb was specifically built to detect exactly that kind of signal. And detect it, it did. What it found was not a campfire. The galaxy contains hundreds of millions of stars. It spans roughly 1,600 light-years. The galaxy contains hundreds of millions of stars. It spans roughly 1,600 light-years. It was so much brighter than expected that some researchers initially assumed the data was wrong, that Webb had misread a closer galaxy's distance, or that some instrumental error had inflated the signal. Follow-up observations confirmed everything. The distance is real. The brightness is real. Here is the analogy I keep coming back to. You plant a seed in your backyard, water it once, walk inside, and 10 minutes later there's a 200-year-old oak tree out there. Full crown, deep roots, thick bark. The kind of tree that takes two people to wrap their arms around. That is the scale of the contradiction we are dealing with. But the existence of the galaxy alone isn't even the most disturbing part. When Webb's spectrograph, NIRSpec, the near-infrared spectrograph, analyzed the galaxy's light, it did not just confirm the distance. It read the chemistry. NIRSpec splits incoming light into its component wavelengths the way a prism splits sunlight into a rainbow. Each element leaves a unique fingerprint in that spectrum. They found oxygen. That single word changes the entire conversation. Oxygen is not a primordial element. There was no oxygen at the Big Bang. That single word changes the entire conversation. Oxygen is not a primordial element. There was no oxygen at the Big Bang. Oxygen has to be manufactured, forged inside massive stars over millions of years, then scattered into space when those stars explode. Every oxygen atom in your body went through that exact process inside a star that died long before our solar system existed. For oxygen to show up in detectable quantities inside JWST Z14-0, at least one full generation of stars had to have been born, lived, died, and scattered their contents, all before the universe was 290 million years old. The math under the standard model simply does not work, and this wasn't a faint signal that scientists are squinting at and arguing over. The spectral signature of doubly ionized oxygen showed up clearly in the data, not a smudge, a signature. The full Webb catalog contains dozens of early universe objects that exceed standard model predictions in brightness, mass, or chemical complexity. But the list of galaxies that shouldn't exist keeps growing every single year since Webb came online. JWST Z13-0 sits slightly closer in time, but is still far more developed than it should be. GNZ11 is so luminous that it appears to contain a supermassive black hole, weighing roughly 1 million times the mass of our Sun. That had no business being that large that early. Sears 93316 briefly held the distance record before follow-up observations revised its position, but it's still anomalous at any redshift. The full Webb catalog contains dozens of early universe objects that exceed standard model predictions in brightness, mass, or chemical complexity. Astronomers are calling it the impossibly early galaxy problem, and that's not a casual nickname. That's the term appearing in peer-reviewed papers, impossibly early. There are 3 serious possibilities on the table, and none of them are comfortable. But no, the standard model has a crack in it. The Lambda CDM framework might be missing something. Maybe dark matter behaved differently in the early universe, clumping faster and giving galaxies a head start nobody accounted for. Or maybe the expansion rate of the early universe was different from what we assume. This connects to the Hubble Tension, the growing, statistically significant disagreement between 2 independent methods of measuring how fast the universe expands today. Both numbers should be the same. They aren't, and the gap keeps widening as measurement precision improves. Some physicists think the Hubble tension and the impossible galaxies are symptoms of the same underlying problem, that whatever our model is getting wrong about cosmic expansion is the same thing making the early universe look too mature. Both numbers should be the same. They aren't, and the gap keeps widening as measurement precision improves. Some physicists think the Hubble tension and the impossible galaxies are symptoms of the same underlying problem, that whatever our model is getting wrong about cosmic expansion is the same thing making the early universe look too mature. That whatever our model is getting wrong about cosmic expansion is the same thing making the early universe look too mature. 2. Star formation was ferociously faster than we thought. Modern star formation is slow because gas clouds get pushed back by magnetic fields, radiation pressure, and stellar winds. The early universe had none of those braking mechanisms, just pure hydrogen and helium in freefall. Some simulations suggest star formation could have proceeded 10 to 20 times faster under those conditions. If true, the cosmic dark ages didn't end with candles slowly flickering on. It ended like a match hitting gasoline, a stellar wildfire burning through enormous gas clouds, and assembling entire galaxies in tens of millions of years rather than hundreds. Three, some of these objects aren't galaxies at all. This is the strangest option and also the most fascinating. What if what Webb is seeing isn't stellar light, but black hole light? When a supermassive black hole feeds aggressively, the material spiraling into it forms an accretion disk heated to millions of degrees, bright enough to outshine entire galaxies. A process called direct collapse could allow massive gas clouds to skip the star formation phase entirely and collapse directly into enormous black holes. Starting out at tens of thousands of solar masses and blazing with radiation from the very beginning. These objects would look, in Webb's images, exactly like extremely luminous young galaxies, but they'd be something else entirely. We already know supermassive black holes weighing billions of solar masses existed less than 1 billion years after the Big Bang. And we've never had a good explanation for how they grew that fast. Direct collapse solves both mysteries simultaneously. Science doesn't stop at the anomaly. The Nancy Grace Roman Space Telescope launches in 2027 and will survey enormous patches of sky at infrared wavelengths. Where Webb finds these galaxies one at a time, Roman will find thousands across a massive survey area. That statistical depth is what the field needs right now. Is JD's an outlier, or is it the rule? Within a decade, we'll know. The extremely large telescope, under construction in Chile, with a mirror 128 feet across, will allow ground-based follow-up at spectral precision never previously possible. When Webb flags something strange, ELT will be able to read its chemistry in extraordinary detail. Together, these instruments will either show that the standard model can absorb these objects with refined parameters, a stress test that makes the framework stronger, or they'll force something larger, a rewrite. Not an overnight revolution, but the slow accumulation of evidence that eventually makes the old framework impossible to defend. There's a line physicists use when data doesn't fit. Nature is under no obligation to make sense to us. JWST Z14.0 is that line made visible. It sits at the edge of observable space and time, completely indifferent to our confusion. It doesn't care that the oxygen inside it shouldn't have had time to form. It doesn't care that it violates the timeline we spent decades constructing. It simply exists, ancient light, captured by a gold-coated mirror 1 million miles from Earth, carrying inside it a frozen snapshot of a universe we are only beginning to understand. We built Webb to confirm what we already suspected. What we got instead was a question we weren't prepared to answer. And that is exactly what science is supposed to feel like. Drop a comment. Which of the 3 explanations do you think is most likely? The cracked model, the stellar wildfire, or the monsters in disguise? Subscribe for more deep dives like this.